The world ocean comprising the combined ocean bodies and about 70% of the global surface. If we combine the shallow seas with the deep ocean basins, the world ocean is about 3,800 meters. Its volume is about 1.4 billion kilometer cube. This represents about 97% of the world's free water. Besides, about 2% is held up in the ice sheets of Antarctica and Greenland, and about 1% represents the fresh water of the world. It is worth remembering that an uninterrupted world ocean and the presence of the 4 continents are of greatest importance to the conditions of obtaining the ocean. After this lesson, you will be able to understand the history and the origin of oceanography, its important tenets and sub-branches. One of the characteristic features of the land and water distribution of the global surface is that the percentage of area covered by water goes on increasing from 70 degree north to 60 degree south latitude. Water covers 28.7% of the belt line between 65 degree and 70 degree north and 99.9% between 55 degree south and 66 degree south latitude. In the northern hemisphere, a total of 60.7% of the surface is underwater, while in the southern hemisphere, 80.9% is water covered. Because of the preponderance of oceanic area, the southern hemisphere is called the water hemisphere, while the northern hemisphere is called the land hemisphere. The existence of the continents and the islands divide the world ocean into 3 oceans, mainly the Atlantic Ocean, the Pacific Ocean and the Indian Ocean. However, there is a 4th ocean, namely the Arctic Ocean, which according to many oceanographers is actually a large sea. All the 3 oceans are considered to have their beginning at the southern tips of 3 continents, namely South America, Africa and Australia. The boundary between the Indian Ocean and the Atlantic Ocean is formed by the 20 degree east longitude. The meridian of the South Cape of Tasmania has been chosen as the boundary between the Pacific Ocean and the Indian Ocean. The Arctic Ocean is also called the North Polar Sea, which is considered by some to be a part of the Atlantic Ocean. In this case, the Bering Strait forms the boundary between the Atlantic and the Pacific Oceans. In all the 3 oceans, equator divides them in their hemispheric parts with their own names, such as in the North and the South Atlantic, the North and the South Pacific, and the North and the South Indian Ocean. The marginal or the adjacent seas are actually parts of the main oceans which have been separated from the open oceans by continents and island chains. Such marginal seas in fact form indentations on the margins of the coast of the continents. If certain parts of the ocean are enclosed by land to a great extent, they are named as Mediterranean. Again, these Mediterranean seas may be further divided into larger intercontinental and smaller intercontinental Mediterranean. The larger Mediterranean include the European, the American and the Arctic Mediterraneans. These Mediterraneans are mere extensions of the Atlantic Ocean and the Australasiatic Mediterranean, which is an extension of the Pacific Ocean. The Baltic Sea, the Hudson Bay, the Pacific Gulf and the Red Sea are intracontinental Mediterraneans, whereas the North Sea, the Sea of Japan, the Gulf of St. Lawrence, the Bering Sea and the Sea of Okhotsk and the Sea of East China may be called the marginal seas. Some other marginal seas have been given geographical names, while others have been named after their discoverers. Oceans constitute the most important part of our physical environment. Life on our planet has been made possible only because of the existence of the oceans. It is a common belief that the first beginnings of a life began in the oceans. In the late 1920s, the British biologist Haldane hypothesized that life began in a hot dilute soup of organic compounds such as sugars and amino acids, which are the building blocks of proteins. Scientists have since met with some success in creating the conditions of a primordial soup that would allow for the development of life under certain conditions. It is theorized that as life evolved in this medium over millions of years, the character of the medium also changed. By the time of the Cambrian age, the oceans were probably very much the same as they are today. As stated earlier, the total volume of all the oceans is 1.4 billion kilometer cube. Enormous quantities of water that fill the ocean basins have great capacity for storing the solar energy. Because of the fact that the specific heat of the water is much greater than that of the land, water gets heated and cooled in longer time than the land. This characteristic of the water influences the climate to a great extent. That is why the climate of the coastal areas remains moderate. The ocean water never remains static. The ocean water is characterized by various types of movements such as tides, waves, ocean currents, etc. Due to these movements of the ocean water, heating and cooling of the sea surface takes much longer time than the land areas. The characteristic of the ocean water greatly influences the atmospheric temperature. Moreover, the origin of the ocean basins and the water present therein are of immense help in understanding the distribution pattern of the land and water on the global surface. Any change in the sea level, as is well known, has far-reaching influence on the land masses as well as the oceans and seas themselves. Climatic variations and changes of the sea level are closely related. Moreover, any change in the sea level is directly related to the continental glacier. Sea level is actually the base level which controls the subaerial erosion in areas drained by rivers flowing into the sea. The fall in the sea level exposes the sea floor to a certain extent, and the gradient is closely related to the action of the rivers. Thus, for any geomorphological analysis, the nature of the sea floor near the coastline and the change in the sea level are of utmost importance. The oceans are full of various kinds of vegetation and organisms. Some of them are microscopically small. Despite the fact that phytoplanktons and zooplanktons are very tiny organisms, even then they form the basis of the origin and development of other marine animals. These planktons, with the help of various chemicals dissolved in the seawater and the solar rays falling on the water surface, create other organisms. The residue of these dead organisms ultimately accumulates on the seafloor as marine deposits. These deposits throw light on the conditions under which the sea animals developed in the remote past. When scientifically analyzed, these very deposits help the scientists in getting a knowledge of the climatic changes that might have occurred in the past geological eras. The ocean water contains all the elements that are found in the rocks of the continental land masses. Economically, therefore, the oceans are called a treasure house of all the precious minerals. It is estimated that 40 pounds of gold and 200 pounds of lead are present in dissolved form in every 1 mile per cube of the ocean water. However, the extraction of these valuable minerals from the seawater is not economically viable at present. But the oceans have undoubtedly vast economic possibilities. It is well-known fact that of the total amount of salt, that is sodium chloride, consumed in the world today, the major portion is obtained from the saline water of the oceans. Provision of adequate food for the fast-growing population in the world is a very challenging and complicated problem. At present, millions and millions of people have fallen victim to the menace of malnutrition. As we are aware, protein happens to be the most important component of our food. According to our scientists, the oceans can supply the required amount of proteins for the entire humanity for many thousands of years. Presently, of the total consumption of protein is about 3% is procured from the fish obtained from the oceans and seas. There exists a great possibility of getting proteins from various types of sea organisms. It is, however, the living creatures of the oceans which are materially more important. The oceans house a vast store of food which may well be needed to feed the growing world population. Vast reserves of petroleum, coal and natural gas, etc. lie deep down the earth in the coastal areas of the oceans, seas and gulfs. Various developed and developing countries are engaged in the exploration of these substances. Thus, it is evident that vast reserves of the minerals are present in the oceans. In the remote past, the oceans lying between the different continents was supposed to be a physical barrier which presented unsurmountable hurdles in making contacts with the inhabitants of different countries. In due course of time, the invention of a steam-driven ships made the sea voyage, particularly in the coastal water, an easy affair. Today, gigantic ships equipped with steam engines and ultra-modern apparatus are busy in the transportation of passengers and goods from one corner of the world to another. With the unprecedented improvements in the science and technology, these ships have been further improved in all respects. As a matter of fact, in the international trade, the sea routes have proved more convenient and useful than the land or air routes. Besides, the oceans have assumed greater importance from strategic point of view. Nowadays, every nation in the world tries its level best to get its control over the sea coast. In the modern age, the United States of America, United Kingdom, France and Russia take pride in their warships and naval fleets. In order to establish their naval bases, the powerful nations of the world compete with each other for their supremacy over the oceans. From the point of view of ever-expanding international trade and commerce, and also from the strategic viewpoint, the acquisition of more and more knowledge about the oceans has become an inevitable necessity. According to Albert Defant, oceanography is the branch of science concerned with the oceans and the phenomena occurring therein. It is a part of the sciences dealing with the earth, and in so far as it gives a qualitative description of the phenomena and belongs to the geographical sciences. H.U. Severdrup, M.W. Johnson and R.H. Fleming have defined oceanography as oceanography embraces all studies pertaining to the sea and integrates the knowledge gained in the marine sciences that deal with such subjects as the ocean boundaries in the bottom topography, the physics and the chemistry of the seawater, the type of currents, and many phases of the marine biology. In fact, oceanography may be regarded as the synthesis of a biological and hydrographic geological knowledge of the waters. J. Proudman defines oceanography as the study of the fundamental principles of dynamics and thermodynamics in relation to the physical properties of seawater and biological studies. As geography has been divided into two major branches, the physical geography and the human geography, so oceanography has also been divided into physical oceanography and the marine biology. However, in the modern age of speculation, the study of a vast subject like oceanography is done under the following branches, keeping in view the characteristics of the oceans and other factors which influence them. However, despite the independent status of these branches, they are closely related with each other, but the interrelationship is highly complex. Physical oceanography. The physical oceanography provides a solid and a scientific base on which marine biology is specially dependent. The physical oceanography is related to the study of the oceanic environment, including the structure of the ocean basins in various kinds of motion of seawater such as ocean currents, waves, tides, etc. It also studies the physical characteristics of the ocean water, namely temperature, salinity, density, and water masses. In addition to these characteristics, physical oceanography also concerns itself with the study of the bottom relief of the oceans, various types of marine deposits, subsurface water circulation, the transparency of the ocean water, and the effect of the light. Physical oceanography is especially concerned with the scientific analysis of interchange and interactions of energy transfer taking place all the time at the interface. Physical oceanography lays greater emphasis on the physical processes operating at the interface of the atmosphere in the oceans. Since sinking and upwelling of the oceanic water are closely related to the origin of the ocean currents, these phenomena are naturally the subject matter of physical oceanography. Chemical oceanography. The ocean water contains various salts and other substances in dissolved form which affect the physical process and biological cycles which are in operation in it. Besides the source, there are many chemical factors which exercise some control over the organic, geological and other physical processes found in the seawater. That is why greater importance is attached to the chemical analysis of seawater in the modern oceanography. Samples of seawater collected from varying depths in the water samples are sent to the laboratory for their physical chemical analysis. Chemical oceanography has for its subject matter various complex chemical problems pertaining to seawater. Hydrogen bonds are the molecules of the surface water. Their covalent bonds, surface tension, electrical conductivity, osmotic pressure, chemical determination of the chlorides, isotopes, etc. are some of the complex chemical problems which are the subject matter of chemical oceanography. Actually, the nutrient cycle is wholly dependent on the chemical composition of the seawater, and this nutrient cycle is directly related to the vast organic world of the oceans. Various motions of the ocean water are largely affected by its temperature, salinity and density, etc. Chemical oceanography also studies the problem of pollution of the ocean water and tries to find out a solution. This branch of oceanography also seeks a solution to the problem related to the dumping of the radioactive industrial waste and the environmental pollution caused by petrochemicals. Marine biology. Marine biology may be considered as the branch of zoology, though it is mainly concerned with the study of the sea as a biological environment. Its subject matter encompasses the study of the chemical composition of the ocean water, planktonic life comprising zooplanktons and phytoplanktons, and different types of marine organisms from tiny organisms to large animals. In other words, the entire life cycle in the oceans is controlled by the physical and chemical characteristics of the seawater. All the gases and minerals necessary for the existence of marine organisms are present in the ocean water in dissolved form. A slight change in the components of the marine environment greatly affects the sea animals. It is worth remembering that changes in the salinity of the ocean water have also far-reaching effects on the marine life. Applied oceanography. Due to rapid development of science and technology, new dimensions have been added to oceanography. Now, oceans are becoming more and more important from the strategic and geopolitical points of view. Besides, economically, two oceans have been assumed greater significance in the modern age. All the mineral reserves found on the continental land masses have reached a point of exhaustion. The vast reserves of the petroleum and coal are on verge of extinction. The rapid depletion of the reserves of other minerals in the present age of industrialization is causing grave concern to the economic planners all over the world. Our land resources are limited and the population is growing at an alarming rate. Under these circumstances, the only hope for the survival of humanity is the presence of vast oceans which might provide enough food for the future generation. Let us hope that in the future our requirements of the minerals shall be met from the oceans. Adequate quantity of protein can be obtained from the marine organisms. Tidal waves may provide an alternative source of non-conventional energy. It should be borne in mind that with the introduction of computers and artificial satellites, there have been radical changes in the realm of oceanography. Let us fully appreciate the role that oceans might play for the welfare of humanity. Marine meteorology. Oceanography and meteorology are so closely related that marine meteorology has been developed as an independent subject. Interactions between the ocean and the atmosphere that take place at the interface have far-reaching impact on both of them. For example, prevailing winds and the wind stress produced by them influence the ocean waves and ocean currents to a large extent. Moreover, warm and cold currents go a long way in minimizing the latitudinal heat imbalance. The effect of atmospheric disturbances on the tidal bores and tidal waves is well known. The sea surface is greatly influenced by the atmospheric pressure, temperature, and atmospheric circulation, etc. Marine meteorology studies the energy exchange, air pressure, and air circulation of the interface between the ocean and the atmosphere. There is no denying the fact that weather and climate exert great influence on the oceans. With the beginning of the second millennium AD, we enter a much more scientific era with the most advanced technologies. With the development of the technologies, we are better equipped to unlock the remarkable secrets beneath the oceans of how its geology works. We become increasingly aware of how fragile our planet is and that we cannot continually pollute our environment and take it for granted. Increasingly, too many people compete for few resources and in the name of making full utilization make some changes which may turn into a repairable damage to the marine environment forever, which happens to be the last frontier of the mankind. Understanding the oceans requires a basic knowledge of geological, chemical, and physical and biological processes and how they interact in different parts of the oceanic environment. And thus, oceanography and its study becomes a crucial aspect.